All right, good afternoon, everyone. So, what I'm going to be covering today, I guess right now, is going to be a previous exam. This exam is going to look very similar to the exam you'll be taking on Monday. So, I'm going to do page 1, page 2, and not page 3, and page 4. Right now, I'm going to do page 2 on my iPad because I can't draw this on my computer. But I will be solving this one as well. So we'll just do the first, second, and fourth page right now. And as well, I'm going to give you some tips on how to be successful in this exam. So first, let's start with how to be successful, and we'll cover these things again in a second. Page 1, easy. Letter everything. Also, you're allowed to use the slides. So use the slides if you don't know a question or don't know an answer to the question. The slides will have all the answers that are questions on here. Nothing that you see here will be something that wasn't covered on the slides. So these two, page 2. Know the difference between whole basis and shaft basis. We'll look at this example and we'll see, what the question is and how it's asked. But know the difference between if it's a whole basis and if it's a shaft basis because they get labeled differently. Page 3. So for a section view, it's going to be a section view on the test. It's not going to be an auxiliary view. So remember, there's no hidden lines in the section view. We'll cover this again when we go through it. But center marks. You need to put center marks in your circles, especially if they're, with all the other stuff that's happening, if you're drawing stuff. Use a ruler. There's no reason not to use a ruler. You're allowed to use a ruler. Because you're allowed to use a ruler, we fully expect that your lines look like they're straight enough to be done with a ruler. Please use a ruler. And then practice first, and then do the final copy if you're printing this out. Practice on a spare sheet of paper. Know exactly what it's going to look like. You have 5 hours to complete this test. You should be fully capable of drawing this at least once, at least twice to make sure you've gotten it correct. And make sure that all the lines are straight and everything, all the geometry works out. Use a ruler. And then page 4. So this one's a little trickier than the one you're going to get on Monday. But first thing, turn off tangent lines. So if you're looking at your normal views and there is a fillet or something, you shouldn't have tangent lines turned on. We'll cover that when we go over it as well, but this one doesn't have any tangent lines, and so it's harder to explain. Maybe I'll adjust it. Turn off tangent lines, though. We should not see any tangent lines. You can't have dimension to tangent lines, so there should be no reason to have them anyways. The only time you show tangent lines is in your isometric view. Don't dimension to hidden lines. It should be self-explanatory, but I see it more often than you think. Don't dimension to anything that's hidden ever. You need to see that thing as a visible line in order to dimension to it. Remember, you're dimensioning for positive and negative cylinders. So here, we'll see it in a second, but here we have like a positive cylinder inside of a negative cylinder. You need to think about which way you dimension to each. Well, I'll give you a hint. For negative cylinders, you dimension as you see it as a circle. So when you're looking normal to that circle, right, you see that hole as a circle, that's how you dimension negative cylinders. Positive cylinders get dimensioned horizontally, so you'll dimension those when they look like rectangles or squares. So remember that. Remember center lines and center marks. I see so many people all the time missing center lines and center marks on their circles, so please turn those on. That's a really easy way to lose points. Another thing, turn on hidden lines. Some people have been doing their entire drawings without hidden lines turned on, which is, you have, unless you specifically note that you turned off the hidden lines because otherwise it gets too confusing, you need to have hidden lines be shown. Another thing is datum. So think about how to best datum dimension. I'm going to go into that further as I build it, but think about datums and how to datum dimension. All right, so let's start with page 1. In ME 212, our class, what materials hatching is applied to the hand drawings of the section views, right? That's iron. So, or cast iron. We can, what do I want? Typewriter. There we go. So I'm going to say cast iron. Name both methods of linear dimensioning discussed in class. So, there's datum dimensioning, right, which is what we use. And then the other one is chain dimensioning. I would recommend printing this off because otherwise you can't. Circle, not that we're going to ask you to circle anyways, I'll just bold it. Oh, what the heck? Oh god. It's adding a bookmark. I have no idea how to use this program. Okay. Well, we'll try that again. There's datum dimensioning, and then there's chain dimensioning. And we use datum dimensioning in this class. Chain dimensioning I see occasionally, and it's incorrect. Can I bold you now? I can. Just go up there. Okay. Match the GD&T symbols to their corresponding names. Perpendicularity. Where is that one? Right? That's over there. That's the little upside down T. So that's going to be D. Oh, we're still bold. Let's unbold you. Oh, didn't unbold it. Whatever. Parallel. Right? That's going to be two lines next to each other. All right, which is the only one there, so that's B. Concentric, that's right under it. C. It's going to be two circles inside each other. Symmetry. We use this all the time. That's the three lines. That's A. And then a position is going to be E. It's the last one, the only one that's left. Name the tool to use to create an internal or female thread. That's going to be a tap, right? And an internal thread would be a die. But a tap creates, an external thread would be a die. A tap is when you tap a hole, you're adding threads to an internal hole. Okay? Which of these section views does not exist? Full, straight, half, line, or broken out? Well, we know that the full section view exists. A straight section view I don't think exists. Half section view exists. A line section view exists. And broken out section view exists. So the only one that does not exist is the straight. If hole size remains constant, name the fit that would produce the smallest shaft size. Okay, so the smallest shaft size, we want the smallest diameter possible. So I'm just going to scroll down to here real quick. We are going to either want the top or the bottom. And the bottom is a force fit, right? So that's going to be a large shaft. We want the smallest shaft size, all right? And we know it needs to be H11, C11, or C11, H11. Which one do we use? Hole or shaft basis? Well, let's go back up here. The hole size is remaining constant. So we're using a hole basis for this type of fit. So it's going to be an H11, C11. Okay? Circle the correct definition of pitch. So pitch, we've covered this a million times before. It's going to be 1 over the number of threads per millimeter. The only one that is 1 over is this guy, right? Can I highlight? Is that something I can do in this program? Yes, I can. So I'm just going to do that. Boom. Didn't work. Try again. Nope. Okay, I don't know how to use this program. All right. Yes. Highlight. Okay, whatever. Well, it's the 1 over number of threads per millimeter. Circle any correct thread callouts. All right, so we have an M12 by 1.25. That's correct. Quarter inch by 28. Unified National Fine. Unified National Fine. And then 20 UNC quarter. That doesn't make any sense. That one's wrong. So the correct callouts would be the first one and the second one. Okay. Make sure you're lettering if you're printing this out, by the way. I think I mentioned that. All right. So let's download the part name bushing dot solid part. So this, when you take your exam, will be one of the files you can download from my Dropbox. I already have it downloaded in SolidWorks, but let's read on. The bushing needs to be placed in a reamed hole requiring a force fit and a precision ground shaft requiring a sliding fit to be used in the apparatus. Okay, let's take that apart a little bit. So we have a reamed hole, right? So that we're going to have a hole basis. I need to get rid of that. My hand. There we go. Reamed hole, right? So it's going to be hole basis. So and it needs a force fit on it. So we're going to have a hole fit basis and force fit, right? We see that terminology there. Okay, so let's remember that one down there. I'm actually going to add a little X right here, so I remember. Okay. Then we have a precision ground shaft. So the force fit's going to be on the outside, right? Because we have a reamed hole we're putting this in. We'll see how this bushing works better in a second, but that's going to be the outside. And a precision ground shaft requiring a sliding fit. So a precision ground shaft, right? So now we're shaft basis. requiring a sliding fit. Where's the sliding fit? Boom. I see the sliding fit terminology right there. Okay. All right. So, create a dimensional drawing, properly dimensioning and tolerancing the outside and inside of the bushing. Other dimensions can be ignored. Okay, that's good to know. So we're coming out here. Let's see. So I have this guy right here, right? It's an IPS. So I'm going to make a drawing from the part. I'm going to make sure I select my English template. Okay, and so we always want the isometric in the top right corner. Go back to my view palette. That thing disappears. Just press this little yellow guy. All right, and then we're going to need a top view or a bottom view, and then a right view, because we need to see that hole, and then we need to see we need to see the interior hole and then this exterior one right here. Okay, so when I said turn on hidden lines, that's this guy right here. Make sure these are turned on, right? Or we're not going to see this hole in the middle. And this hole needs a center line, right? Now going back to what we were talking about earlier, you need a center line for all holes. We're going to add a center line there. The center mark got added automatically over here. That's what these horizontal and vertical lines are. All right, so we need to add our fits now. So we're going to go to Smart Dimension, and we are going to add, let's add this fit first. Okay, and see how this is an isometric? That's another thing. Make sure you're an ANSI, which will make your, it'll make all the dimensions, oh, did it fix it? It did. It'll make them all easier to read. All right, so we know this needs a fit. So let's go back to our sheet real quick. And let's see, what did I say that needed? That needed a force fit, or sorry, the inside one needed a precision ground shaft requiring a sliding fit. Okay, so that's going to be over here. So we are on a precision ground shaft, so we're on a shaft basis, and it's going to be the inside hole there. So we're going to have that G7. Okay, so let's go back to SolidWorks. We're going to add a tolerance, a fit with tolerance, so I can see what's happening here. And we need our G7. See if G7. Okay. So we have our G7 there. We can see we can't see what's happening here. So I'm going to increase our precision here so we can see what's going on. Actually, I'm going to keep that one the same. I'm going to change this one, right? Because I don't want all the extra stuff over there. Okay, so we have G7 right there, right? Because we're doing the hole on a sliding fit, right? Sliding fit, precision shaft. It's a shaft basis. We're doing the hole, which is the one on the left, right, between these two. Okay. Oh, oopsies. All right, so now let's do this outer diameter. So remember, when we're doing holes that are negative, right, we have to do them when we see them as circles. For positive cylinders, we have to do this hole on the outside. So let's add this guy here. And this one needs a fit as well. And which fit did this need? Let's go back and check. So that is going to need right, this is a hole basis because it's a reamed hole. So when we're looking at this list vertically, a force fit with a precision ground shaft. So force fit, H7U6, we're going to need the U6 part of this one. So we're going to add a tolerance again. And I'm going to do fit with tolerance so we can see the numbers. And what we say, U6. So we're going to need U, it's going to be at the bottom of the list, U6. And I'm going to add some precision to this. See what's happening. All right. Move that over a little. Okay, and this is what you want to turn in. When you make, let me move that over a little, move this to the center. When you turn in your part, right, you're going to save this as a, PDF, and as what it is now. And I guess we'll cover that in the end. That'll be. But this is now done. Make sure you save this sheet. I'm actually not going to save it for now because I don't want to overwrite any copies I have of old exams and stuff like that. But that's what the sheet looks like. Hand this sheet in as it looks here. So now for problem 4. Let's take a look. Where was it? Here it is. Okay. We'll do this one on the iPad in a minute. I'll upload that separately. All right, so now we need to create a fully dimensioned SOLIDWORKS drawing of the part named Dell on canvas. Obviously, this test was different. Our part is going to be downloaded. Excuse me. Our part is going to be downloaded. When finished, print out the drawing and staple it to the back of your exam and submit the zip. That's also different because you're submitting it online. All right, let's take a look though. So one good thing to do is always to look around the part before you get it. All right, so I see we only have some stuff going all the way through, right? This is like a little computer top piece, right, where the CD slides in there. We got some part for USBs and all that, headphone jacks and such. All right, so we have some triangles going in the side here. I see over here we have a positive cylinder and a negative cylinder, both of the same thing. We have some square cutouts for USBs or something. We have this little piece over here called a power button, and then we have this whole thing that's at an angle, and that looks like everything. You can always, if you want to be careful, you can click this up here and slide through with a sectioning tool, and that way you can kind of just look through the whole part, see if you're missing anything. Doesn't look like we're missing anything. Okay. All right, so let's create a drawing from this. Ooh, what was this in? I think it was in inches. No, it was in millimeters, I remembered. Yeah. So I need a metric drawing template. That one. Okay. Bring over the isometric. This is probably going to take more than one page to do, right? So I'm not worried about, make sure it's within the lines. I'm not worried about running out of space. Okay. All right. So what should we do first? Let's take a look at, just it from the side. Can we get a top? That's probably what I want. Yeah. Okay. So here we're going to be dimensioning not as much the stuff over here, right? Because we're going to need an auxiliary for that, right? To get the side there. But let's just start with this. Okay. So again, make sure hidden lines are turned on so we can see what's happening. And then tangent lines will be turned off, but there are no tangent lines on this, so that doesn't matter. Excuse me. But you would, the way you change it is, sorry, I didn't explain that. You can't see what I'm doing. Right click on the edge, tangent edge, and you'd say tangent edge is removed. This one doesn't have any tangent edges, and so it doesn't matter, but you'd remove those tangent edges. Okay, so let's talk about dimensioning. What I want to dimension here is I want to dimension everything that's basically on this top flat face, everything that I can. So I want to show what's happening with these holes. I want to show what's happening with this piece, and we're going to do a detailed view to show what's happening on the inside here. So let's start dimensioning. First thing I'm going to do is just come from the bottom, and I'm noticing two things. First of all, we're in the wrong unit. We need to be in MMGS, right? That's going to make that a lot better. And second of all, I need to change my sheet from ISO to ANSI, even though it said it's an ANSI. My computer's broken. Don't worry about it. Okay. 15. All right, and I'm going to bring this in a little bit, right? Because I think I'm going to have a few dimensions I'm going to have to call out here. Add that in. Oh, I need to go back on a smart dimension. Add that in. 20. We can adjust exactly where they are later. Add this in. 40. And from here to these holes, right? You just click on that. And that's going to be 68. And that's all I'm going to do for here. Then I just want to define how big this piece is. All right, and what I'm talking about, I mentioned earlier, about datum dimensioning. Datum dimensioning is when you have one line, right, that you come down to for all your dimensions. Because if you were measuring with, a caliper, or you're checking these dimensions later, you'd want to come from the same point to there, from the same point to there, from the same point to there. Okay, and that's because of what we use for tolerancing. Basically, if each one of these lines, can be plus or minus a few, percents of, a few mil, maybe not a few mil, that'd be too much. But basically, if each one of these could be off a little, if you go from here to here, and then from here to here, if you were off by a little with this line, now dimensioning from here to here, you're going to be off by even more for this line. So we want a datum dimensioning because it's a little more accurate with what we do. So we go one line at the bottom that would be easier to measure. It would be easy to measure from here to here, from here to here, from here to here, etc. And so that's what we do. And you want to have datums be consistent and easy to measure. So the next thing I'm going to do is datum from the side here to this little plus sign, to our center mark, not a plus sign. All right, and so because I did that, I don't actually have to do anything else when I come in here with my detail view, right? So I'm going to come in here with the detail view. I'm going to start here and go to about, I'm going to go to about there, because I just want the top of that line. That'll make sense in a minute. All right, so I'm going to come over here with that. What's at the door? No worries. Mid-lecture. All right, so what we're coming to in here is now we need a dimension off of our top piece here. So because we gave our datums for where this point is, we can now use this point as our datum for other stuff. Because otherwise it would be, we'd have too many points coming all over the place here. So first thing we're going to do is I'm going to show the distance between these two. Oh, we need to be in smart dimension. Come on, give me the distance between these two holes, please. Come on. There we go. Okay. Distance, and we can bring that out there. Then I'm going to do the distance between this and this, right? We'll bring that out there. And then the distance between this and this, okay? All right. And now we want to do these holes in here, right? These are a little confusing. So let's remember that it's like this is the normal surface, right? And then this is a hole. This in between part goes down. This is another This is another surface that's level with the outside surface, and then there's another hole. So it's a little confusing. But basically, what we're going to come and do is we're going to come in here. And we're going to add a call out here. So let's do that. I don't want to change my leader, I don't think. I just want to give a specified depth. There we go. Okay. So what we're going to do here is we're going to add a hole depth, noting how deep this hole is, right? Because it doesn't go all the way down, all the way through the part. So we're going to add our depth measurement there. And before that, or yeah, I'll do it after, it doesn't matter. So before that, I know from earlier, from when I checked it, that depth is going to be 2. It's going to have a depth of 2. I'm actually going to add this depth a little cleaner. I'm going to add it after the end here. So let's add it there. Oh, see, didn't add it late enough. There. Boom. There we go. Okay, with a depth of 2. So that tells us how deep that hole is. So that's good there. And now we need to do the same thing for the hole in the middle. So we'll add that. My depth just disappeared. That's all right. All right, we're going to do the same exact thing. And this hole is 3.5 deep. So just add that in. Okay. And I'm going to make these a little prettier. putting them right there. Just far enough to where they don't I don't want them to intersect with one another. What if I put it down there? There we go. All right, it's all about making it as clear as you can. So I think that's fairly clear. And then we just need to show how wide these are, right? So let's get this width here. These need to be at a width. And I'll show that these are the same, right? We'll do a little PYP to show that this is going to be the same for all of them. And you're coming down so you can see it's the same. And then we need to dimension. Yeah, I think that's good there. Let's see. Move this over a little just to do some housekeeping here. I'm actually going to take this whole guy and move it there. That there, right? It's all about just being the cleanest and clear we can be. I think that's what I need there. Yeah, that looks pretty good. All right, so now that we've done that, let's add a, I'm going to bring this up a little bit. There. Okay, so now we need to add a sheet, right? Because we've ran out of space, but we haven't given all the dimensions we need to give. So now let's work on some of the horizontal distances. So let's do that here. I'm going to come in here. I'm going to open up my view palette, refresh. Let's give, or actually, you know, I think we can save some time here. I'm going to do something crazy. All right, so what's going to happen here is I'm going to do a section view. And I'm going to do a multi-pointed section view here. Oh, it's going to be an auxiliary. I'll just add a few here. Okay. This here. All right, so let's start the section here. And then let's add a few breaks in here. So let's add a break here. And here. Bringing it down to the middle there, right? So we can see our height there. Okay. And then we'll come add another break. We'll add a break here. That'll make sense in a moment. But actually, I'm going to change how I do that. I'm going to come across here again. Let's change how that happens. Because I want to go to a different whole depth. Right, so we'll bring that depth down to there. Let's do that again. And let's chop it here. So we can cut straight through these lines. Don't you let me go there. That's all right. Close. Let's do that again. Coming back up after that hole. Just through, you know, halfway through here so we can get that depth. Okay. So here, I'm actually just going to add this down here because it will make more sense. All right, so now that we have that section, let's move this up a little to have more space. I'm going to make this isometric a little smaller. Custom scale 1 to 1. What if we do 2 to 3? Perfect. Okay. Bring this up and out of the way a little. Okay. All right. Now that we have this section, right? The beauty of coming through all these points here is that now we have all these different points that we can now see. So we can add these in here. So let's take a look. All right, let's zoom in and see what we got. So we have all these points. Let's just start, I guess. So start with our dimensioning. We're going to come to the top there, and we're going to have our datum be the bottom point. So let's bring this out, and then we need to come to this point here. Height after that, and then to the bottom. Right, because then we can show that depth. Then we'll come over to here for our stuff at the bottom. We'll move this section BB to here, I guess, for now. That might need to get moved more later. We'll show what angle this is coming off at. The angle there. And then at the total distance, right? Because this is flat. This is flat. So we can give the total distance there. Okay. All right, that doesn't look bad. And then for what's happening in here, I'm going to do another detailed view of what's happening right there, because otherwise that stuff is too small. So let's come in here and let's add a detailed view there. Develop those two objects over here. So now they're a little bigger. We can see them a little better. Because with these positive cylinders, right, we need to dimension them when we're looking sideways to them. So let's dimension them like this. Right? So we have that 4. I'll bring that 4 outside. And we're going to need to add, to show that it's a diameter, we need to add our diameter mark there. Okay. Did I add that above, up here? Where did I miss that? I don't think so. Okay, that was the only time it hadn't happened. But I need to add that diameter there so it's not just 4. And then we just need a depth of this hole. Or sorry, not the hole, you could add the depth. I'm going to keep that inside. You could have added the depth here in a note, but it's a little more clear over here. I'm actually going to bring that outside because that's a little messy. Okay. All right. So now let's clean this page up a little. Detail A, detail C, section BB. Okay. That looks pretty good. All right. Next page. So we're going to need a detailed view or sorry, not a detailed view. We're going to need another section view to get those inside triangles. Right, there are these triangles up here. And then we're going to need an auxiliary view to get this. So we already have a view right here that that we could take an auxiliary from, so we'll just take it from that. Okay. Yes, thank you. Delete you for now, because that's not exactly what I wanted. Can we do, how do I want to do this? We could take an auxiliary view from there. I think if we take, that's going to take our sectioned auxiliary. What if I move you? All right. I don't know why that D is staying there. There we go. Let's think here. Well, let's start with actually, I think we can solve this, okay? Because we can start with I think this is the side with the 3 holes, right? Yeah. So remember again, you don't need an isometric on this page. But let's make sure, so coming in here, let's make sure we have hidden lines turned on, show what's happening on the inside. And then we're going to want a section view coming straight through these 4 points here, right there. So we can take that off. And it's got some funky points in here, which I'm not that worried about right now, because I just care about dimensioning these top pieces. And then we can take an auxiliary view off of this. So let me bring this over. Is there any way to make this pretty? Let me delete this section for now. I will work on that section later. Okay, so for now, we just need to dimension what's happening with this face, right? So let's that section now. We'll do pick a datum. I think this datum works pretty well. Actually, we'll do the datum at the top right, because the datum up here, if we choose this line, is the same than we used on the other side. Here. 68, and we need to get these holes in here. Oh, try that. There we go. 74. Three. And then the total distance. Okay. And now we need, what do we need here? These holes, we need to identify how large they are. TYP. And we need to know from the edge to the hole that distance. I'll bring outside. Actually, I'll bring it over here. I might need that space in a second. What else do we need? We need the horizontal up on this this part up here. To know how wide that is. Okay. All right, so that's all we need there. Now all we need is a. Ooh, you know what I'm gonna do? Do I have a view that? Oh, nice. So now we have this, right? So now we've shown everything. The only thing we still need are these triangles. So what I'm actually gonna do. Oh, this document hasn't been saved. What I'm actually going to do is do a broken out section here. And I'm going to come here, here, here. Okay. Do I need to connect that? Try that again. It's the other day. All right. Come on. Give me my spline tool. Right there, probably. It's much hard to judge how the spline is going to act. There we go. Specify a depth. That should be good. 10 mil. How thick is this object? Actually, we probably only need to go down 5, so let's go down 5 millimeters, see how that looks. Too deep? Not deep enough? Let's try that again. That was obviously probably not deep enough. Can I get that section, broken out section? Am I missing it? I can't see it? Okay. I guess we will do it again. Can I just choose this spline to break out? I can. Let's try 10. 10 work? Nope, 10's chopped all the way through. Jesus. One more time. Let's try 2.5. Boom, there we go. Okay. So now we can see what's happening on the inside here. So let's get our Jesus, Haley. All right, let's get our angles on here, right? Which we can add. That angle does not look very good. Let's try that again. Let's get a depth. Does that look better? That's better. A horizontal distance to the side, 1.25. To bring that off the page a little. Distance between them, right? Because this would be patterned out. Go from here to here. Want me to make this prettier in a second. I can bring it down. Okay, 12, and then a distance between each one, just put over here, which is 9. The reason we can kind of jump around here is because we're defining this pattern. We're not defining, datum-wise this stuff. So let's make this a little prettier. Bring this down just a smidge. Okay, 1.25. That 12 I'm happy with. That 9 I'm happy with. Put them on the same point even. Boom. Okay. So get me out. I don't know why this got highlighted in orange all of a sudden. Disregard that. Okay, so you would save this as a PDF. I think we've got everything we need here. Yeah, that looks good. Yeah. Actually, so, ooh, good point. Not good point. I was thinking to myself. So we need to add the depth of these, right? We need to know how deep these are for 2 reasons. One of which, because we need to know how deep they are. The second reason being, we can't ever have any dimensions on here or views on here that don't have any dimensions attached to them. Everything if you have a view included, you need to use it for some dimensions. I was about to say, oh God, we have to add dimensions to this somehow, but I just realized we didn't get the depth on this first page here for what's happening up at the top. So we added it. We added them over here. Now this view has dimensions on it, important dimensions as well. Excuse me, hiccup. All right, so what you do is you would save this file, save as PDF, and save it wherever you want to save it to. I'll save it to my desktop. And then it's going to ask you what sheets you want to save. You want to save both of them, right? Because otherwise you only save one of these 2 sheets. So you save those, and then you would also add your name and all that kind of stuff, and that whole 9 yards. And then we have that there. Boom, look at that. There's your drawing. So I will say this is kind of a hard drawing. There are a lot of dimensions. There's a lot of things you need to do to make it look clear. Your drawing is not going to be this hard. I'll tell you that right now. So don't worry about it. But yeah, that is the answer to that. So you'd submit that as a PDF. You'd submit your bushing, right? This is a PDF, and then also, come on. There we go. You'd also submit this as a PDF, and then you would submit the SolidWorks files zipped up to us. Yeah, and that's it. I will cover the drawing portion next, but that was page 1, 2, and 4. So that should hopefully answer any questions. If not, ask your instructors. Yeah. Have a good day, guys.